Hello, today we're going to be covering two sections, so don't get scared, they're easy sections. 10.3 and 10.4, square roots and solving quadratic equations, which obviously involves square roots. So hopefully a lot of this is just review. But technically the definition of a square root, the number a is considered a square root of b if a squared equals b. So I have an example for you over here. We know that 4 squared is 16, that negative 4 times negative 4 is also 16. So basically we can say that the square root of 16 could be either positive or negative 4. And that's kind of just an example. I just want to show you a symbol here. We use this symbol for, it's called a radical, because it's so cool. It's just radical. Anyway, and then whatever is underneath the symbol is what we call the radicand. So the 36 here would be considered the radicand. The principal square root of the number is the positive square root, and then we have the negative square root, which is the negative 4 there. But again, as long as, you know, a squared equals b, then we consider a square root. For example, you could say that plus or minus 6 are square roots of 36 because 6 squared is 36 and negative 6 squared is also 36. So you probably already knew that, but just reminding you there. So we have some examples here. It wants us to simplify these expressions. The square root of 64 is going to be 8. So let me pick a different color here to liven things up just a little bit. And again, that's because 8 times 8 is 64. So we're looking for a number that multiplies by itself twice to get 64. So there you go. In this case, you can see there's a negative in front of it, but we treat the square root the same. We know the square root of 100 is 10, and then you put the negative in front, so that answer would be negative 10, and that would be the negative square root. That's not considered the principal square root. The principal square root of this is 8. The principal square root of 100 would be actually 10, and then because of the negative in front here, we're going to make that negative 10. In this case, you want to, it says plus or minus, so you want both. So basically you want to split that into the square root of 9 over the square root of 16 and make those separate square roots. And the square root of 9 is 3 and the square root of 16 is 4. And of course you have your plus or minus. So the answer there would be plus or minus 3/4 for part C.
Yeah, feed him.
Hi, that was my husband. Anyway. And then you have the square root of 0. Again, it has a plus or minus. It's trying to kind of like throw you off there because the square root of 0 is just 0. And there's no such thing as positive 0 and negative 0. It's just neutral. So the answer is just 0. And then, of course, we have our last example here, the square root of negative 16. There is no such thing as the square root of negative 16. This is what we call undefined. And again, the reason is because there is no one number that you can multiply by itself to get negative 16. You could have a negative 4 and a positive 4, but by definition, those would be different numbers. Like with the case of the 8, you have 8 times 8, not 8 times negative 8. So there's no way to get a negative 16 from multiplying the same number twice. So because it's not possible, we can't take square roots of negative numbers, so we just call it undefined. So you can simplify these expressions in a similar fashion, and then we'll move on. The next thing we want to be able to do in this section is to tell whether or not a radical is rational or irrational. And I will remind you that rational means that it's going to have a decimal that terminates or that repeats. So you could have, for example, 0.5 or 0.25 or 0.33333 repeating. Those will all be considered rational. Irrational is when you have decimals that don't repeat and don't have any pattern. Just want to remind you about that because the easiest way to do this is to take out your little calculator. And we already know, hopefully, that the square root, oops, let's not do that. We don't want the eraser here. The square root of 81 is 9. So obviously there's no decimals involved in 9, so that's considered rational. So we call this rational. This little guy, if you don't know what it is, you should kind of see the 144, the square root of 144 is 12. But this is 1.44, so we're going to go second on our calculators and go square root of 1.44, and we get 1.2. And because of that negative, you're going to have a negative there. And this is also rational. And remember what I said earlier, as long as the decimal stops, like it doesn't keep on going forever, or if it has a pattern, it's considered rational. So this decimal stops, so it's rational. And then we go to the square root of 5, so we're going to put negative square root of 5, not 2, 5. And you're going to get negative 2.23606, and it just keeps going. And you'll notice that it just keeps on going forever, and there's no pattern. This is considered irrational. Okay? Decimal that has no pattern and it keeps on repeating. So that's irrational. And then over here we have, like we did earlier, the square root of 4 over the square root of 9. The square root of 4 is 2, the square root of 9 is 3, and 2/3 is actually 0.6 repeating. And so because it repeats, it has a pattern, this is considered rational. And then we have over here, same thing, square root of 1 over the square root of 3. And if you take 1 and divide it by the square root of 3, you're going to get craziness, I can assure you. You're going to get 0.57735 ... Again, the decimal keeps on going forever. There's no pattern, so we call this irrational. All right, irrational. So, in a similar fashion, I would like for you to determine whether or not these 4 examples are rational or irrational. All right. And then we have these 2 little examples. There's a lot of fun ones here. They're kind of related to each other. We want to estimate the square root with example 3. And then with example 4, we're going to use our calculator to get the exact square root. So it says between what 2 consecutive integers is the square root of 14.52? And that might sound really scary, but all you really have to think about is some of the perfect squares that you're aware of. And where does 14 fall in between? For example, 9 is a perfect square because 3 squared is 9. Okay? And so is 16. And the number 14.52, okay, is kind of sandwiched in between. In other words, 14.52 is smaller than 16, but it's bigger than 9. All right? And the square root of 9 we know is 3, and the square root of 16 we know is 4. So we don't really know what the square root of 14.52 is, but we would expect it to be somewhere between 3 and 4. And so when it says what 2 consecutive integers it's between, it's going to be between 3 and 4. And the closer to the 16 it is, the closer to the 4 is. It's not going to be like 3.1. It's going to be closer to 3.7, 3.8, or something like that. So then in example 4, you can actually use the calculator to find the exact square root of 14.52, which is, like I said, approximately 3.8 at nearest hundred, so 3.81. All right? So notice that because the 14.52 is closer to the 16, your decimal is closer to 4 as opposed to closer to 3. So that is all you have to do for those examples. And you can try that little guy right there. Happy hunting. And that pretty much takes care of 10.3. And then we're going to go over to 10.4. And 10.4 is not very complicated either. But we're going to be using, obviously, this knowledge of square roots to solve quadratic equations, which obviously all have x squareds in them. So to solve an x squared, you have to take the square root, which is why we have to know about square roots. So solve each equation by graphing. So we've already done that in 10.1 and 10.2. We've been doing a lot of graphing. So I'm going to graph these really fast. Don't be scared if I do it faster than you. It's just because I'm doing it a lot longer. So x squared minus 4 means that I'm going to shift my graph 4 units down. So you could make a t-table if you wanted to, but I don't have enough space for all that. But basically, if I let, what's happening here is you're going to imagine that normally we're used to seeing y equals x squared minus 4. And what we're doing right now is we're replacing the y with the 0. So that's where the 0 is. Instead of it saying equal to y, it's saying equal to 0. So we're looking for the places where the y coordinate is 0. And that would be anywhere on the x-axis. So we want to graph the function and then see where it crosses the x-axis. So the first thing I would do is, if I was making a t-table, I would say, well, what happens if x is 0? If I plug in a 0, then 0 squared is still 0, and 0 minus 4 is negative 4, which is where I'm getting this point from. And then if I want to plug in 1 squared is 1, and 1 minus 4 is negative 3. So when x is 1, it'll be negative 3. And I'm going by 2's here, so negative 3 is in the middle of 2 and 4. And then if I plug in 2, 2 squared is 4, and 4 minus 4 is 0. And because of the symmetry, we can expect this guy to be here and this guy to be there. And so I graph my parabola like so. All right, and you can see from my graph that the places where the y-coordinate is 0 is right here, this guy, and that guy, okay? The x-coordinate here is 2, and the y-coordinate is 0. And over here, the x-coordinate is negative 2, and the y-coordinate is 0. And that's what I'm looking for. When is the y-coordinate 0? So my answers would be that the y-coordinate is 0 at positive and negative 2. So that would be my solution. Okay? In a similar way, we can graph this guy. This one is actually a lot easier because we've done this before. This is your parent graph. Y equals x squared. Okay? So that one's at 0, 0. When x is 1, 1 squared is 1. So we just do that little guy. You can do 2 squared is 4. Negative 2 squared is also 4. So you can get this little graph going on there. And again, in this case, the only time when you get 0 is right here. Okay, so right there you have the x-coordinate is 0 and the y-coordinate is 0. So my answer would be x equal 0 for part B. That's the only time that you get the parabola equal 0. And then you've got this guy over here. And over here we've got plus 4. So again, if x is 0, you're going to get 4. So there's my dot right there. If x is 1, then 1 squared is 1, plus 4 is 5. So when x is 1, and again I'm going by 2's in this case. So if I get negative 1, of course we have some symmetry here. So we have a parabola that's way up here. And the question is, when does it cross the x-axis? Like when does the y-coordinate equal 0? Well, it's never going to equal 0 because as you can see, it never even crosses the x-axis. So here we have no solution. It's never going to equal 0. Okay? So I kind of want to take a moment right now to look at these 3 graphs because these 3 graphs show us the 3 possible responses that you can have when you're solving quadratic equations. There are only 3 options. It is possible to have 2 solutions. In this case, you can see clearly that it crosses the x-axis 2 times. So you can have 2 solutions, and we have plus and minus 2. Then you have the case where it's sitting right on the x-axis, and you only have 1 solution. And there's my 1 solution. And then you have the case where the graph never crosses the x-axis, and therefore it has no solution. Okay, so those are the 3 possible options that you can have. So that's kind of important, so you kind of want to keep in mind that it's possible to have 2 solutions, 1 solution, or none. All right, so you can now solve these 3 equations by graphing. And then we have our last example for today, and that is to solve this little guy algebraically. And so believe it or not, this is actually probably the easiest one of them all. When you're solving a quadratic like this, it is very important that you isolate the x squared part. So you kind of want to see this is the x squared part right here. So I want to isolate that. So this 98 needs to move to the other side. So I'm going to add the 98 to the other side. And then that will give me 2x squared equals 98. And then I divide by 2. And then I get x squared equals 49. Remember, you do not want to take the square root of both sides until the x squared is by itself on either side of the equal sign. You never want to take the square root like right here because there's still a 2 in there. You want to wait to take the square root until the x squared is by itself. So now I can square root both sides, and anytime you take the square root of both sides, you have to remember to put plus or minus, and the square root of 49 is 7. So in this case, we have 2 solutions, positive and negative 7. All right, so that's pretty much all you have to do is isolate the x squared, and once the x squared is isolated, then you can take the square root of both sides and get your 2 answers. Don't forget to put plus or minus. So these are the last examples that I need you to do in your notes. And once you've done that, you will have completed the lesson for today. And I will see you in class on next class period. Thanks for watching.